Okay, let's go back through hypothesis testing and let's cover the corners. So if you remember, continuous, continuous, all right, and discrete. So continuous y, continuous x, so this is your x, this is your y, this was regression. Okay, so let's talk about regression. Basically, we need our y to be continuous. So one example for most companies is profit. And you could do that in dollars or percent. Okay? And then we want to know what drives profit. And as a purist, regression x's are supposed to be continuous. So for example, gross margin. You could do that in percent. You could look at employee turnover as a percentage or as a raw number. Okay? So we have a continuous y, we have a continuous x or x's. Now, Minitab and some software will let you add a categorical variable. So for example, maybe our y is home prices and we have square footage and the acreage of the property, and you might add a categorical value of 1, 2, or 3 bedroom. Okay, so bottom line is, with regression, we're trying to see how much of the movement in the y is explained by the movement in the x's. So and it doesn't have to be 1-to-1, but for example, you would get a 100% r squared. So that's basically the statistic we're looking for in regression. You can kind of ignore the p-value per se because it's the r squared that tells you whether or not the strength of a relationship of a regression model. But an r squared of 100, meaning 100% of the movement in the y is explained by the x. 1 is very rare. You would probably only get that in a mechanical or scientific type operation, but that would say, for example, let's say my y is speed of my car, and my x is the pounds per square inch that I push on the accelerator pedal. Now that might go 51, 52, 53, so this is a 1-point movement each time, but each time I got 10 miles per hour. So this would be what we call a strong positive correlation, okay? Strong positive. In business, you typically just look for what we used to kind of call the fat pencil test, not to offend pencils, but you look for some type of strong movement where things seem to move well together. You might have a little outlier over here where, in this example, some store is new and didn't make any money. You're wanting the r squared to get stronger and stronger as you add x variables. So the overall theme of regression, and here's the hypothesis, the null is that your x, and this is funny, is not a predictor. See, I find regression is one of those things where people get a little confused because they want the x to be true. So for example, every company out there wants sales to predict profit, but you have to tell them to assume it does not. So sometimes I say, well, just pretend you're explaining it to some, person who's lived in the bush of some country somewhere, and you walk up and go, does sales predict profit at Exxon? I have no clue what you're talking about. So that's the null hypothesis. The alternative is that the x or x's is a predictor. Okay? Is a predictor. And then what we do is we run our statistics, and of course if the p-value is less than 0.05 or 0.10, whatever you choose, you would accept the alternative. But again, that isn't as important as the r squared. The r squared explains the strength of the relationship, how much of the variation in the y is explained by the x. So that's really what we want to look at. Again, this would be above 90%, I would think. This looks to be 80 to 90%, not a bad r squared at all. So This is an example, we call this in the country a turkey shoot. And that's an example where there's absolutely no relationship. And that, actually, I've done this test before. I had a client that was a major U.S. retailer that wanted to grow EBIT. And I would just ask each department, what do you think drives EBIT? And then I would show them just a simple example of whether or not they were onto something. So in this example, the HR department said that employee turnover. And I love their thought. I mean, that we should never criticize people for thinking about hypotheses. We should criticize them for not testing them. I love the thought that as more people leave the company, maybe 100 per month versus 0, okay, you would think in that example that profit would go down. So you would have a negative relationship, something like this. But in this example, there was absolutely no correlation whatsoever. One of the stores had the best profit and no turnover. Another store had the best profit and high turnover. So that's basically the regression equation. It's pretty straightforward. You don't have to worry about normality as much. But the big takeaway here is, are the X's, and there's your buzzword. I always look for buzzwords that tell me what hypothesis to do, and that is my X a predictor? Okay, and then whatever software you use, in Minitab, I'll just go to Assistant Regression, and I'll run the regression model, and we can look at p-values, but most would agree it is better to look at the R-squared and see the strength of the relationship. Okay, so that's the corner for regression. Next video, we'll move on to continuous Y, discrete X.